Folks, welcome back. It's Chris Good, and here is the final installment in our CNC machined electric guitars. Started in Fusion 360. Gonna finish up on the Decatur Maker's big CNC that's controlled by Mach 3. Here's what we managed to do so far. We worked really hard to get a beautiful neck that's all one body at this point. This blue one right here. In the previous video, we described how to get that transition from here, which is just lofted between two neck profiles, to here, this headstock that we extruded from a sketch. It's this middle part in between that was quite challenging, but we made it. We did it. We did it in a different style guitar, but the same principles apply. So that loft between the neck itself and the headstock we did in the previous video in a Mustang style or Jazzmaster style headstock. Here we're back to the telly, and it's time to bring this into the real world. We're going to bring this into reality, bring this electric guitar neck. Gonna carve it out of wood. Better yet, we're gonna let the CNC do it. Now, I've only changed a couple of things that you might not have seen, but they're really simple, and so I'm not gonna go through how to do it right now. One is a sketch element that you can see here. Let me hide the body and show you the element that I'm talking about. And that sketch was brought over from the original main one, and I edited this part down. Here's the part I'm talking about. That center line, I've actually dropped it down below the surface of the top of the neck by 3/8 of an inch. This is going to be the path that the bit follows to cut the truss rod slot. And it is lowered down to the depth of the height of the truss rod, which in this case is 3/8 of an inch. And it is the length of the truss rod that I bought. I got one from StuMac. I think it's 22 or 24 inches, something like that. And, well, we can just see 18 inches is how long it is. I was thinking of the bass guitar. And so you'll need to make this line in the position that's correct for the truss rod that you want in the position that you want. This one ends right here at the heel, just this end of the heel. So you'll have to take the neck off of this guitar to adjust the truss rod. Hopefully that won't be too much of an imposition. You could flip it around, but make sure enough of it is going to stick out into the headstock so that you can access the truss nut. Okay, the only other thing that I did is I created two new bodies, and these are cylinders that are on the center line, so they're centered on that same center line that runs through the entire guitar and the entire length of the neck. And this one is just for a 3/8 inch dowel that we've got lying around the wood shop, and it's going to have a peg for our flip milling operation go through it. And this one fits a cylinder that is a piece of copper pipe that we're going to connect to our plate centering input into the CNC. And we're going to use this to center the back side of the neck when we flip it over for flip milling. Those are the only things that I've added. So you might not use this method. You might want to zero it somewhere else, but let me just show you how I'm planning on doing it, and we'll create the toolpaths, and then you can take what you like out of this video. Let's hide the sketches. Let's bring back that body. Notice I made this extra thing here. Let's highlight that. It's called center on this. It's just the loft from the neck, so I just made a copy of that before I brought the whole body together. Let's do that, and then we're going to go over to the manufacturer side. This is where we're going to do our toolpaths. And I've got a new setup here. This one's labeled itself setup number 4. I'm going to call it neck. This is the front of the neck. All right. The one that the fretboard is glued up on. And let's edit this. So we're going to... I think model orientation's okay for this one because the y-axis is pointed that way. And we're centered. Actually, what I want to end up doing is centering on this body. So that's the thing that is in the very center of the stock. Now, we're done with that. And instead, we're going to use the whole body right here. We want to make sure that the stock is wide enough to accommodate the headstock in both directions and long enough to accommodate both of these pins. Now, this is just a piece of stock that I've got. I'm going to change it to relative size box. Sorry, to fix it was already on fixed size box. I do happen to have a piece of wood. It's 4 1/4 inches. Maybe it's not quite 30 inches long. Maybe it's 28 inches long. And that's going to be enough to fit everything, except you'll see that if I center the model, it's actually centering on that middle chunk of the neck. So I'm not going to center it on the y-axis. I'm going to say it's offset from the back by, let's say, oops. Well, I'm going in there. It's offset from the front by not 2 inches, but like 8 inches or so. And that should be okay. How's that? Nope, not quite. 7? Good. Okay, now everything fits, and that's fine. The only other thing we'll want to change on here, well, first of all, let's see the height of the stock. I've planed it down to 3/4 of an inch because that's as tall as the heel is. And it's also the distance from the top of the front of the neck to the back of the headstock, to this plane down here. So you see that these two pieces, the heel, the bottom of the heel and the bottom of the back of the headstock, they're in the same plane, so they're coplanar. And the whole thing really doesn't have a dimension that exceeds 0.75 inches. And I find that it makes a lot less sanding if you just start there. And just then you won't have a lot more sanding to do. You might have noticed, though, that these cylinders actually stick out through the stock. And that's okay. We're going to create a toolpath that goes that deep into the cylinder, that goes into the, oops. No. Oh, and we messed up our stock. There we go. Okay. Let's go back and edit that stock one more time. All right. Model orientation, we have centered on that body. We're using stock. That's a fixed size box, 0.75 inches. We're going to hide center on this. I'm going to go back and show that body one more time. Okay, we're back. Ooh, problem, because in the Z, we've actually centered this piece. And what we want to do is offset it from the top by 0 inches. Okay. Now everything's centered properly. What I was trying to get your attention to is this other peg actually sticks out through the stock as well. These two cylinders are going to go, we're going to make cuts that go into the sacrifice board, and that will be very important when we flip this whole stock over for the second side. This is going to be the first side that we're going to do. There's just a few milling operations in this. Let's fix one more thing and get our origin to this left corner, and then we're going to use the XY plate to center it. All right, so this is a piece of aluminum that goes over this corner. The bit finds the hole and sets XY 0 to here. All right. First things first. Let's get our straight bit out, cut these holes, and cut the holes for the pegs that go all the way through. And we will also mill out this flat piece right here. So these are all 2D milling operations. They are They're pockets. They're pocket operations. And I'm going to choose a 1/4 inch flat end mill. I like this one, my upcut spiral. It says 4 inches long. You don't need 4 inches long. I'm not going to use 4 inches long, but this is the profile of the bit that all you really need is the diameter and the fact that it's flat on the bottom. So we're going to use that. And we're going to pick several different things. Let's cut that pocket. All right. Let's do these holes on the bottom. Let's get this cylinder. Let's get this one as well. And I think that'll do it, as long as it's not going to hog out that entire thing. All right, let's make sure that we do multiple depths. Don't leave any stock. And our max roughing step down is going to be half the diameter of the bit, so 0.125. Okay. I got a bad feeling about that giant area blue. I know? Yeah. What on earth? Let's fix that. Oh, come on, monster. Okay. Doing a pocket here. Do that pocket. This one. And then these little circles. That's 6. You'll want to make sure you get the diameter of those holes just right before you choose that diameter. That would be in the design side. Okay, no stock to leave. Multiple depths. 1/8 of an inch. Just so we don't hog out too much material at a time. Okay? It automatically chose 0.11875 as the step over. I think that's fine. Let's see what this toolpath looks like. Nice. Oops. I just noticed something though. Instead of that bit, let's use the 1/4 inch that I wanted. Okay, recalculating. Sweet. Let's get a little preview, shall we? Faster, faster. Just checking out what it's going to do. Just making a few passes there just to get down to the surface. One hole, and another hole, and then the rest of these. Great. I like it. Let's keep it. We got another 2 operations to do, and these are going to be using the same bit, and so we're going to export those with the same path. The first one is 3-dimensional, and it's a parallel path, and all that is the scoop. Well, let me choose the bit first. So we're going to use a ball end mill, and the model that we're going to use for this, the model surface, is this face. We want that tool to be able to extend outside the boundary, and we really don't need multiple passes because it's going to step down very nicely. So let's see what that is. Oop, ugh. I did not tell you to do that. How about this? We'll change this to the selection. That's the machining boundary. Okay, that's our face. Don't include the setup model. There. Boom, boom, boom. Oh, except I want it to be a little finer than that. So let's fix that first. And we'll bring the step over down to maybe 0.02. And that'll be nice and smooth. Be ready for sanding. Ooh, that's pretty fine though, isn't it? It's also coming off the lip there. That's weird. Oh, tool center and boundary. There we go. How about 0.05? Because we are going to need to sand that a bunch. That's just to get us started. There we go. I like it. While I'm thinking about that bit, there's one more two-dimensional path that I want to do, and it's called a trace. Trace is just going to follow a line, and a line that it's going to follow, same bit. I do want multiple passes, and these are axial offset passes with the step down. I'm going to say a 0.1. Actually, no. I'm going to say 3 step downs. I am going to make it go both ways so it doesn't go all the way back. And here's a trace. Curve selections. So we need to find a curve. So I need to show sketches. And the sketch element that I want to trace is this one right there. Let's see what that does. Hide your sketches. Watch what this trace does when we simulate it. See? Model your stock. Oh, it's cutting out our truss rod slot. Awesome. Okay. That's it. That's it for the front of the neck. All right, so let's preview this whole setup here. Let's simulate everything that we're going to do. Just give it one last check. Yep. That's what I told it to do, all right. Okay. And how long is this going to take us? Machining time of about 20 minutes, yeah. This is probably as expected. Okay. That's the easy part. Here's the other thing. We're going to take this setup. We're going to duplicate it. And now, let's bring these sketches up so you guys can see what I'm working on here. And now we're going to activate this other duplicate sketch, which is not neck front, it's actually the neck back. But now, since we're looking at the neck back, the only difference between these two setups, well, there isn't one right now because we just duplicated it, but here's what we need to change. We're going to be milling from this side, and we can't zero with this box point. So we're going to choose a new 0, and that's the only thing that we're going to do. We're going to choose, instead of a stock box point, we're going to do a selected point. And remember this big 1-inch pipe? That's the thing that we use to drill into our sacrifice board, right? I made this other 1-inch pipe there, where this part's actually in the same plane as the heel. So that's going to be the origin. And the other thing that we need to do is be able to select our X and Y axis. So we actually need to flip Z, get it up that way. Well, let's select Z and Y. And there we go. So now Z is up, which was down from the front. Y is that way, X is to the right. All right, and then leave it alone. So now, this is very important to check. You want to make sure that, oh, and the other thing is that we need to drop this down so that this part is inside the model. Let's edit that one more time. See how that messed up? Let's fix it. Gonna make sure that it's not messing around. Offset from top, change that to offset from bottom. There we go. Because now the top is the bottom's the top. And now the only difference between these should be the origin flipping. Do this and look at it from a couple of different angles. And you shouldn't see anything change except the origin. Zoom in on that just a little bit. I'd really like to make sure that it's correct. Otherwise, you know, you might take a really nice piece of wood. Okay, that angle looks good. Let's do from the side. Flipping. Flipping. Great. Okay. Only a couple of cuts on this side too, but a couple of them take a long time. One set of cuts is done with a flat end mill, and these are well, they're pocket cuts, and depending on the thickness of your material, you might need to do this or not. If you've cut it exactly, you planed it down to 3/4 inches exactly, then you won't need to do these steps, but oops. That's the geometry that I wanted. Don't need to do multiple depths here. Let's see what that looks like. In the preview? Yeah. I mean, you know, if your stock's exactly correct and it's not at all warped and twisted, then you probably don't need to do that, but it might be a good time to go ahead and do those passes. I'm not going to mess with this step over because it's not a big a deal. Other thing I want to do is a profile cut, or what they call it, a contour cut here. And we're going to follow the contour of the entire neck. We want to add tabs. That might be too many tabs, so I'm going to increase the tab distance. That's probably okay. I just wanted to hold it down while, let's change it to 2.5. Oh, no. Tab distance is 2.5 inches apart. There we go. Yeah, I think that that'll be fine for our tabs. The only other thing we want to change is our multiple depths. Let's bring that down to 0.125. That's fine. Okay, see what that looks like. Great, it's going to step down, it's going to leave those tabs. And we want to do these two first. Alright, so both of those together can be exported as a single toolpath for Mach 3, which we've covered how to do in a previous video. The last thing that you'll need to do is another parallel path using the ball end mill. There we go. And this step over, I'm going to make 1/10 of what it is nominally, 0.0125. And I'm going to choose this face, and this one, and this one. I also want to avoid surfaces here and here. Alright. I want the tool to travel outside the boundary. And let's see what that looks like. Now, here's the trick. You want to make sure that without the body there, you can see from one end of it to the other, so that it's not going to drag across the middle of your neck and cut it in half, like a toolpath that I created one time. And you see that really fine step over? That's going to save you a lot of sanding, I think. Hey, some people like to make these by hand, and some people like to let the machine do it. Okay. That's the back. These leftover toolpaths are from when it was flipped, so I can just delete those. Get rid of those. Let's look at the whole thing. Just give it a little preview. Simulate. Speed this up. Make sure it's going to do what I want it to do. It's a profile. The contour, I mean. Yeah. And in just a couple hours, you should have a neck that's ready for sanding. Put your truss rod in. Glue that fretboard that you already carved out right on top. I think we're closing in on the end, believe it or not. Okay. Check one more thing, the machining time on the back of the neck. About an hour. Yeah, so keep an eye on it. Make sure everything's going well. I would love to see the results of someone following these instructions. I hope that it works out. I wish you good luck. It is a lot of fun making guitars on the CNC. I'll show you some pictures in the next video, and I will see you.